this complex number can be plotted as a point in the two-dimensional Cartesian plane called the organ plane here. So that is the distance between these 2 points, right? So that is the diameter, half of that will give you the radius, right? Also the same form, argument of z minus a by z minus b, right? But it is not an equation, it is inequality. So less than 3 pi by 4. As we know, these are the various topics of the chapter complex numbers. Here in this class, we are going to talk about the locus of a complex number. What is locus? See, any complex number, for example, this complex number z equal to 3 plus 4i. So this complex number can be plotted as a point in the two-dimensional Cartesian plane called the organ plane here. So this is a point 3, 4. You can take this real part as the x coordinate and the imaginary part is taken as the y coordinate. Now we can plot this as a point. So any complex number can be plotted as a point in the two-dimensional plane, right? Yes. Now you have another complex number which is of the form k plus I k squared. But this is different because k is variable. K can be any real number. So unlike the previous one, so here k is a variable. That means this z is not a fixed complex number. It can take many values. If you vary the value of k, we will have different values for this complex number z. For example, if you take k as 0, we get 0, 0. If k is 1, so 1, 1, k is 2, so 2, 2 square. If you plot all these points, this collection of points is called the locus, right? In the first case, we have only one point. In the second case, we have many points, a collection of points. This collection of points is called the locus of the complex number, right? Yes. Now you plot all these points 0, 0, right? So 1, 1, 2, 4, 3, 9, similarly minus 1, 1. You join all these points, we get a curve. This curve can be called the locus of the complex number given by this, right? K plus I k squared, right? So this locus, right? This curve here, that is a parabola, right? So this parabola is the locus of the complex number. See, the locus in real equation, right? Real equation means we have two variables x and y. To denote a point or denote a locus, we need the two variables, right? X, y. But here we'll use single variable z only because z itself is a combination of two variables, right? X plus iy, so x, y. So that is denoted simply by z. So any equation in complex number, right? So that can be written, any equation, the locus of a complex number can be written in terms of just one variable z, okay? Unlike the real equation where we need two variables x and y, right? So here you see the x coordinate is k and y coordinate is k squared. Now we can eliminate this k. K is the parameter, we can eliminate that. So how will you do that? So if you square this, right? So y equals k square, but k is x, so y equals x square. That is the equation of parabola in real, right? Real equation, right? So that is the real Cartesian equation of a parabola, okay? But when you want to write this in terms of the complex variable z, what is x actually? X is the real part of the complex number z. So in place of x, we can simply write real part of z. Similarly, what is y? Imaginary part of z. So imaginary part of z equals the real part of z square, right? So this is the same equation. So y equals x squared. So that is written in terms of the complex variable z like this, right? The imaginary part of z equals the square of the real part, right? Now here, all the locus equation like equation of circle, straight line, anything in complex number is written in terms of one variable z only, right? So this is a simple example of a locus, right? So this is one of the examples of a locus. Now we are going to write many more locus equations, right? From the very basic equation and important equations like this, and some unimportant equations also. We will do that. So there are some equations like the equation of circle. All these are very important. And some equations like equation of straight line in complex number, these are not very important, but we are going to cover all these things here, right? So let us do one by one all the equations of locus, right? So the first locus here is So this is the first locus, right? Modulus of z minus a equal to r, right? Here r is a real number, right? A positive real number, because modulus of something has to be always a positive real number, but a is a complex number. It is not necessarily real, right? It can be a complex number, right? So modulus of z minus a equal to r, right? So a is a fixed complex number. It is fixed, right? For a particular equation, it is fixed, but z is variable, right? So for different values of z, we have different points. Joining all the points, we get a curve. What kind of curve we'll get? See here, now we have to understand the geometrical meaning of modulus, right? So what is the modulus of the difference between two complex numbers? Modulus of z1 minus z2, or simply modulus of z equal to say modulus of z. What is the meaning of modulus of z? So we know that modulus of z geometrically means the distance of the complex number from origin, right? From origin, the complex number is at a particular distance, so that distance is called the modulus of z. Similarly, what is modulus of the difference between two complex numbers? Modulus of z1 minus z2. So that means geometrically the distance between these two complex numbers. So the distance between these two complex numbers is modulus of z1 minus z2. So here also it is of the same form, modulus of z minus a equal to r. But what is the meaning of modulus of z minus a? That is the distance between z and a. Right? So a is a fixed complex number. Let us fix a. So a is fixed here. Okay. Now where is that? Z is at a distance r from a. Right? Distance between z and a is r. Okay. So that's all. But z is not the only point here. There are many points satisfying the same condition. Right? So is there any other point which is at the same distance r from a? So at the same distance, right? So there are many points, right? Joining all the points, we get a circle. Right? So that means z is not a fixed point, z is a variable points joining all the values of z, right? So we get a curve, right? In this case, it is a circle with center a and radius r. So this is the first equation of locus we have to remember, right? So this is the most important locus of all, right? So modulus of z minus a equal to r is a circle, equation of a circle with center a and radius r. So a is the center, right? That is a complex number. A can be a complex number. For example, if a is 3 plus 2i, that means 3 comma 2, that is a point. So that is the center of the complex number and r is the radius of the complex number. So that is the first equation of locus you have to remember. Now, as a particular case, what is this equation, modulus of z equal to r? So that is a particular case, right? So a is 0. So that is a circle with center 0, right? That means origin and radius r, right? That is a particular case of that one only. So z, modulus of z equal to r is a circle with center origin and radius r, right? So this is the first locus. Now based on which, let us do some questions. Okay. Here the equation of a circle is given. We have to find its center and radius. First of all, is it the equation of a circle? The equation of a circle in complex form should be of the form modulus of z minus a equal to r. If it is not of that form, you should be able to bring it to that form. Only then we can find the center and the radius. So the equation given here is, so modulus of 2z plus 3 minus 2i, so that equals 5. Okay, so 2z is there. We don't want this 2, right? Because we want to get it in the form modulus of z minus a. So 2 can be taken out, right? Because it's a positive real number. So if you take this 2 out, so it will become z minus, we need a minus, so we can write it as minus of minus 3 plus 2i divided by 2. So that equals 5. Okay, so we can divide by this 2. So we get modulus of z minus minus 3 plus 2i divided by 2. So that equals 5 by 2. Now it is of the form modulus of z minus a equal to r. Now we have brought this equation in the form modulus of z minus a equal to r. So now we know the center of this circle, that is a, and radius is r. Comparing these two equations, we can write the center and the radius, right? The center of this circle is a. So that here is minus 3 plus 2i divided by 2. And similarly, the radius of the circle here is r. So r here is 5 by 2. So that's all. So that is the center and radius. See here, see, when the equation of a circle can be written in this form, there are many other forms of equations of circle, but this is the simplest one. Modulus of z minus a equal to r. We can directly write the equation of the circle. Then we can write the center directly a and radius r is this, right? So that is the answer. R is 5 by 2 and the center is minus 3 plus 2i by 2. Okay. Here also we need to find the center and radius of the circle given. But this circle equation does not resemble the circle equation that we know. We know the equation of circle modulus of z minus a equal to r. But this equation is not of that form. So to find the center and radius, we have to bring this equation into that form, right? So let us simplify this equation and get it in that form. Only then we can write the center and radius, right? So the circle equation given here is this one, modulus of z square plus a z bar plus a bar z plus k equals 0. See, k is a real number, right? So a is a complex number, right? So a can be imaginary also, but k is a real number. See, now it is not of that form, so we bring it to that form. Modulus of z square can be written as z bar, right? So that is a formula, z multiplied by its conjugate, so that is modulus square. So plus a z bar plus a bar z plus k equals 0. Now, so we can, from the first two terms, we can take this z bar out, so it will become z plus a. Similarly, from this you take a bar, so we get z plus k by a bar, right? So we don't want that. So we want same z plus a, only then we can factorize it. So you get, you add this a. Okay, we've added this a. That means we have added a bar, right? That is not given in the question, but we have added this a bar. So if you add, we have to subtract also, or you add it on the right hand side. So that equals a bar. And also this k is taken to the other side, so that is minus k. So now it is okay, right? So a bar we have added, so here also a bar, so that is cancelled. So minus k. Okay, that's all. Now from these two terms, again we can take out z plus a. Yes. Now if you take out, it will become z bar plus a bar. So that equals, so a bar, that can be written as modulus of a squared. So minus k, right? Yes. Now this is a complex number. Z plus a is a complex number. What is this? Its conjugate, right? We can write it as z plus a, the whole conjugate, right? So this is the conjugate of z plus a. This is z plus a. If you multiply a complex number by its conjugate, so we get the square of its modulus. The square of modulus of z plus c, right? Same formula we used here also. See, the square of the modulus is that multiplied by its conjugate. Okay, so that equals, so there we have modulus of a squared minus k. Now if you take square root, so we get modulus of z plus a equals square root of modulus of a squared minus k. Now we have the equation in the form modulus of z minus a equal to r. Then we can write directly the center and radius. But not z minus a, we have z plus a. So that means what is the center here? So comparing with our known equation, so the center here is not a minus a, z minus of minus a. So center of this circle is minus a, and similarly the radius of the circle is the right hand side, mod z minus a equal to r. So r here is this one, square root of modulus of a squared minus k. So that's all, right? So this is the center of the circle and this is the radius of the circle. See, just like the basic equation mod z minus a equal to r, even this one is remembered as a formula, right? So if you don't remember it, so you have to do these steps, okay? But if you remember this particular equation can be treated as a standard equation, right? So apart from the basic equation mod z minus a equal to r, we also have this equation. If you remember the center and radius of this equation, so we can write the answer directly, okay? So if you don't remember the equation, so we can do these steps, but it's better to remember, right? So mod z square plus a z bar plus a bar z plus k. If this is the form of circle given, we can directly write the center to be minus a. So that is the coefficient of this z bar, right? Negative of that. And similarly, the radius can be written using this formula modulus of a squared minus k. All right. So this is the center and radius, okay, of this circle equation, okay. Here a complex number z satisfies certain condition, modulus of z minus 7 minus 4i equal to 2. We have to find the minimum and maximum value of modulus of z. See, it is not just one complex number satisfying this condition. There are many complex numbers that satisfy this condition, right? Among all the complex numbers, we need to find those complex numbers which have minimum modulus of z and maximum modulus of z. See, it is the same question which is already done using the inequality, right? The modulus inequality. You can also do this question by using the geometry, right? So let us do both the method, right? See, you can use the modulus inequality. See, it is of the form, this is the question given, modulus of z minus 7, okay, take out, so plus 4i, so that equals 2. Now it is of the form modulus of z1 minus z2, okay, it is of the form mod z1 minus z2. We know the inequality mod z1 minus z2 is greater than or equal to mod z1 minus mod z2. This is one of the inequalities. There are the other inequalities also, but so let us use this one, mod z1 minus z2, but that value is given to be 2, greater than or equal to mod z1. So we have taken z1 as z only, so mod z minus mod z2, so that is 7 plus 4i modulus, okay. So that means we get modulus of z which is less than or equal to this 2 plus 7 plus 4i modulus, right? The square root of 49 plus 16, so that is root 65. That's all. Modulus of z is less than or equal to this number. That means this must be its maximum value, right? Modulus of z is less than or equal to that number, so that is the maximum value. Similarly, if you use the other inequality, right, mod z1 minus z2 greater than or equal to mod z2 minus mod z1, or less than or equal to mod z1 plus mod z2. So if you use the other inequalities, you get the value of the minimum value of modulus of z also, right? But that's not what we want, right? We want to use the geometry, right? Because the complex number z satisfies this condition, mod z minus a equal to r. That means z is a point on a circle, right? So which circle? Z lies on a circle with center 7 plus 4i and radius 2, right? So z can be any point on the circle. There are infinite points, right? But among all the points on the circle, which point will have modulus of z minimum or maximum? So what is the meaning of modulus of z? Modulus of z simply means the distance from origin. So we want to find that point on the circle which is closest to origin, right? Because modulus of z has to be minimum. That means the point which is closest to origin. So which point is closest? Similarly, farthest point. So you draw a line from the origin to the center. Where it intersects that circle, so that is the point closest to origin, because all other points are farther, right? So this is the closest point. Similarly, the other end, okay, so that is the point which is farthest, because other points are closer. So you just find the distance from origin to that point where the line meets the circle, and that is the minimum value of modulus of z. Similarly, the other point will give you the maximum value of modulus of z, right? Simple geometry only. It looks like a question of complex number. No, it is only geometry. See, we have to realize that it is a circle. Other than that, there is nothing much about complex number here. Only simple geometry is involved here, right? See, it is a circle. Now we have to find the point on the circle which is closest and farthest from origin, right? Yes. Now let us find. So let us find the minimum value of modulus of z. To find the minimum value of modulus of z, what do you do? That distance we have to find from origin to that closest point. What do you do? From the origin to the center, we can find the distance. That distance is taken as d, right? From the center to origin, that distance is d. From that, you subtract the radius, right? If you subtract the radius, we get that distance, required distance, right? That's all. So d minus r, that's all. So that will give you a required distance. Right? R is known, radius of the circle, and also d is known. So what is d? From origin to that point. So that is the modulus, right? Modulus means what? Distance from origin to that complex number. So that is modulus of 7 plus 4i minus r is known 2. So this is square root of 65 minus 2. That's all. That is the minimum value of modulus of z. Similarly, we can find the maximum value of modulus of z. So maximum mod z is d plus r here, right? D plus r from origin to that center plus the radius. So that will give you the maximum value of modulus of z. So that is okay. So this we have already written, root 65 plus 2. So that's all. So this is the maximum value and this is the minimum value. So which can also be found using the inequality method, right? But this is a better method, right? So we know clearly which is minimum, maximum. Sometimes this is confusing. So let us use this method, right? So the moment you have an equation like this, modulus of z minus a equal to r, you have to understand that the point z lies on a circle, right, with center this and radius is also known. Okay, so that's all. So it is a circle. After that, using simple geometry, we get the minimum and maximum value of modulus of z. Okay. This question is similar to the last question. Here also we have z satisfying the condition modulus of z minus 8 minus 6i equal to 2. That means z lies on a circle whose center is 8 plus 6i and radius is 3. So z lies on a circle. Okay, now we have to find that value of z which has minimum modulus of z, which means the z which is closest to origin, that we have to find. Not only the distance, we have to find that complex number also. In the last question we only found the minimum value of modulus of z and maximum value, but here we have to find that complex number which has that minimum modulus. Alright, yes. So same thing, same method. What do we do? From the center to the origin, right? So that distance we can find. Okay, yes. Then subtract the radius, we will get the modulus of z, right? So for minimum modulus of z, so we want to find the minimum modulus of z. So that equal to, see, from the center to the origin, right? That is the modulus of 8 plus 6i. So that is the distance from origin to the center. From that you subtract the radius. right, minus the radius. But what is the radius? 3. So this will give you the modulus of our required complex number. So that is, I think this is 100, right? 10 minus 3. So that is 7. 7 is the minimum modulus of z, okay, which means we got the modulus of z, okay, for minimum complex number, minimum modulus. So the value is 7. But that is not enough, right? We want to find that complex number also. How to find that complex number? How to find? See, we only know the modulus. From that, we have to find that complex number. How to find it? We can do by two methods. One is, see, it lies on the same line as the center. If you join origin to that complex number or origin to that center, so they are the same line, right? That means they'll have the same argument, right? Argument will be same. So you can use the argument to find it. Or we can also do one thing. We can use section formula, right? See, what is the section formula here? So there are two complex numbers. What is that? Origin and center. Now this complex number lies somewhere between them, right? But in what ratio does it divide? See, origin is here and the center is here. What is center? So that is 8 plus 6i. Origin and center. Our required complex number lies between them, okay? In what ratio does it divide? We know the exact length though, right? This is the radius, so that is 3. And the total length is also known, 10. So 10 minus our modulus of this, so that is 7, which we have found. We can use section formula, right? So the point which divides these two complex numbers, right? Line segment joining them in the ratio 7:3. So that way we can find it. So our required z equals, okay? So what do you get? So 7 multiplied by this complex number. So 7 multiplied by 8 plus 6i. Plus 3 multiplied by this complex number, that is 0. Divided by 7 plus 3. Okay, that's all right. That is a formula for the section formula, right? Point which divides in the ratio, right? So like mz2 plus nz1 divided by m plus n. So that's all. So this is the answer. So this will give you our required answer. This is 10, or we can write it as 7 by 5. If you divide by 2, it is 4 plus 3i. So this is the complex number. This is the value of z that lies on a circle that is closest to origin, right? So that's all. So this is one of the methods of finding it, right? So we can use that argument method also, because the complex number z and center lie on the same line joining origin, which means, so that is a multiple, right? We can write z as some k multiplied by that for say 8 plus 6i, k multiplied by 8 plus 6i, and that k can be found using this modulus, right? So that can also be done, but this is a simple method, right? Yes, so section formula. Simply we know both these points, and this point lies between these 2 points, dividing in some ratio. Using the ratio we can find the answer, right? So the modulus, the complex number z lying on the circle which is closest to origin, that is this. Similarly, the farthest point, that can also be found using a similar idea, using the external division, right? But the answer to this question is simply 7 by 5, 4 plus 3, okay? This question is similar to the last question. Here also we have z satisfying some conditions. Modulus of z minus 3 minus 2i is less than equal to 2, not equal to 2. Which means not only points on the circle, but also points inside the circle, because less than 2, that means what? The distance is less than the radius. That means the points can be inside the circle also, like the circular disc. Not only points on the circle, but also points inside the circle. Okay, now z satisfies that condition. Now we need to find the minimum value of modulus of 2z minus 6 plus 5i something. So that means among all the points satisfying this condition, right, which point will have the minimum value of the modulus given by that expression. Okay, yes, now we know that z lies on a circle, or interior of the circle, right? See, it's given that modulus of z minus of 3 plus 2i. So that is less than equal to 2. So that is a circle with center 3 plus 2i and radius 2. So that lies on the circle or inside the circle. Now we want the minimum value of this expression, right? 2z minus 6 plus 5i modulus. So we want this value to be minimum. Okay, what do we do? Take out this 2. So 2 if you take out, so z minus 6 minus 5i, okay, divided by 2. So what is this? 2 can be multiplied. So we want to find its minimum value. So see, 2 can be finally multiplied. We want the minimum value of this expression. What is that? Z minus this thing. See, z is not fixed. Z can be any point on the circle. So z is not fixed. But this is a fixed number, which means this minus this, that means what? The distance between these two numbers should be minimum. That means the value of z should be closest point to this, right? So that is the value of z we need. See, last question also we did the same thing, but that point was origin. We want to find the modulus of z minimum. That means what? Point which is closest to origin, but here the point which is closest to this point. That is the only difference. Instead of origin, we have this point. See, first of all, z lies on a circle with center 3 plus 2y and radius 2. Okay, yes. Now this point 6 minus 5y by 2 somewhere, right, outside. Okay, now this point, that distance should be minimum. What do we have to do to find the minimum value of this? So what do you have to do? So 2 multiplied by from this point to the center, right? Find the distance from this point 6 minus 5y by 2 to the center. So that distance is taken as, say, d. Okay, so that is the distance. From that you subtract the radius, that's all. So distance minus the radius. Yes, now we have to find this distance from this point to that center, right? So that distance can be found using the difference, the modulus, right? So modulus of the difference. Distance means what? The difference between the complex numbers, and modulus. So that is, so 3 plus 2y, that is the center, minus of this is 6 minus 5y divided by 2. Okay, that is d, right? The distance between center and that of given complex number. Now minus r, so radius is known, so 2, so minus 2. Okay, so that's it. So this is 2 multiplied by, so this is 3 minus 3, that gets cancelled, 2i minus 2i plus 5 by 2. Okay, so that is 4 plus, so 9 by 2i. So it is simply 9 by 2i modulus minus 2. So that's it. So that will give you the answer. This is 9 by 2. So this is 9 minus 4. So that is 5. So that's all. So 5 is the answer. 5 is the minimum distance. Alright. Yes, that's all. See, simple geometry, right? So z lies on a circle, r inside the circle. Okay. Now we want the distance between that z and this point to be minimum. Okay. So that means closest point. So same idea. From the point to the center you find the distance. Subtract the radius, we get the required answer. But see, it makes a difference if the point is inside the circle, right? If this point itself is inside the circle, what is the minimum distance? That is 0, right? Because all the points inside the circle we can consider. So the same point. So if the point is inside the circle, the distance between that circle and that point is 0, right? Because not only circle, any point inside the circle also is taken into account here. Now what do you do? But is this point inside or outside? How will you know? So that you have to check. When will this point be inside the circle? The distance between that point and the center is less than the radius. Okay, that means this value becomes negative. Suppose you're getting this value negative. Okay, so see, what is this? 9 by 2 minus 2, that is positive, right? If this value happens to be negative, that means we understand that the point is inside the circle, then it is different. That is not the answer. Okay, but here this value happens to be positive, we know that the point is outside the circle. So that means, so that is the correct answer only. From the point to the center, find the distance, subtract the radius, we get our required distance. Alright, so that's all. So that is the answer 5. Okay. This time we want the argument to be maximum. Mod z minus 10 equal to 6. So that is a circle with center 10 and radius 6. Okay, now among all the points on the circle, which point has maximum argument? Okay, so 10 means that lies on the x-axis. Okay, that is the center, 10, 0, and also the radius is 6. So that is a circle on which our required point z lies. Okay, now which point has maximum argument? What is the argument? So take a point on the circle, right? Take a point, any point on the circle. Now join that point to origin. So that line makes some angle with the x-axis. So that is the argument, right? That angle. Now if you change the point, the argument will also change. Now we want a maximum argument, which means you keep increasing this angle of this line, keep increasing this angle. So the maximum angle is when that line is a tangent to the circle, right? So if you increase it further, no contact with the circle, because no value of z satisfies that. Now if it is the maximum argument, that means that line becomes a tangent to the circle. That means that point is what we need to find. If you draw tangent from origin to that circle where it meets, the point of contact is what we need to find. Okay, yes. Now let us find it. Yes. So how to find it? Let us first find the modulus of z. Okay, yes. Now that is simple. See, this is a right angle triangle, right? From the center to that tangent. Okay, if you draw the line, so that is perpendicular to the tangent, right? So That is a right angle triangle now. What is the base here? That is the hypotenuse, that is 10 units, and radius is 6. So that means what is that distance? That is the modulus of z. So modulus of z here is, you can use Pythagoras theorem to find, right? So square root of 10 square minus 6 square, right? So that is 8. Okay, so square root of 64, so 8. So 8 is the modulus of our required complex number. We don't need just modulus, we want that complex number itself. Okay, so what do we have to do? Only modulus is known, so we need the exact complex number. Let us use the polar form of the complex number. What is polar form? So z equals r cos theta plus I sin theta. This is the polar form of the complex number. R is the, not the radius, but the magnitude of the complex number. So the modulus is 8 and also the argument of that complex number is theta. Then this is our required complex number. Okay, so what is R here? That's what we found here, 8, modulus of that, so 8. But what is cos theta? We can find it, right? That is a right angle triangle. What is that cos theta? So that is the base. So that means the adjacent side, which is 8 divided by the hypotenuse, that is 10. So 8 divided by 10 plus I sin theta. What is sin theta? The opposite side, that is the radius 6. So 6 divided by 10. That's all. So this is our required z, which is at the topmost point. I mean the point of contact of the tangent. Okay, so that's it. So this is what do you get? So 8 by 5 multiplied by 4 plus 3i. Okay, so that's all. So that is our required answer. So 8 by 5 multiplied by 4 plus 3i, that is the complex number lying on the circle which has the maximum argument, right? So draw the tangent, the point of contact will have the maximum argument, right? So that is the answer. This question is just like the last question, but the center of the circle is not on x-axis. So the center is 5 plus 7i. Now z lies on a circle with center 5 plus 7i. Now we have to find that value of z which has minimum argument. Alright, so just like the last one, so simple geometry or maybe some trigonometry we have to use. So let us find it. Yes, now this is a circle. Center is 5 plus 7i, okay, and radius is 5. Now you join origin to the center, okay, and that is the radius is 5. Now that distance is square root of 5 square plus 7 square, that is root 74, right? So from the center to that origin, right? So that is 64. That means our required z, which has minimum argument, will be the lowermost point. That means you draw tangent this end, okay, draw tangent. So where the tangent meets that circle, that is where our z lies, right? See, that point will have minimum argument. So that z is what we need to find. But what is the modulus of z? So modulus of z equal to, again using Pythagoras theorem, the square root of, okay, so 74 square, root 74 square, the 74 minus 5 square, so that is 25, so that is 7 only. That means the modulus of z is 7, okay, just like last question. Here also we found the modulus, but we need the argument also, right, if you want to use the polar form. So how to find the argument? Let us take the argument to be theta. Theta means what? That tangent makes angle theta with the x-axis, okay, so that angle theta is what we need to find, but that angle is not known. But what is that angle? Say let us take that angle to be phi, angle of that right angle triangle, phi. So phi is known. What is phi? You can find cos theta from that right angle triangle. We can find cos theta, tan theta, whatever from that triangle, phi. But what we want is not phi but theta, right? So we want theta. So how to find theta? Okay, but what is theta plus phi? So that is known actually. So tan theta plus phi, tan theta plus phi. So that is known because you see that line joining origin to the center, okay, so that point is 5,7. That, see, it's like this, from origin to that point, see, 5,7. This angle is only theta plus phi, okay, from the origin to that center, the line joining that makes angle theta plus phi with the exact x-axis. Okay, now what is theta plus, what is tan theta plus phi then? So tan theta plus phi equals, what is tan theta plus phi? The opposite side, that is the y coordinate 7 divided by the adjacent side, which is 5. So tan theta plus 5 is 7 by 5. But we want the value of tan theta. Okay, let us find tan theta. So use the formula tan a plus b. So what is tan a plus b? So tan a, which means tan theta, so plus tan phi divided by 1 minus tan theta tan phi. Okay, we just use the formula tan A plus B, so that is 7 by 5. But we know the value of tan phi also. What is the value of tan phi in that right angle triangle? So phi is the angle of the right angle triangle. What is tan phi? That is opposite side, which is 5, divided by adjacent side 7. So 5 by 7, that is the value of tan phi. So that is tan theta plus 5 by 7 divided by 1 minus tan theta multiplied by 5 by 7, so that equals 7 divided by 5. Okay, now you multiply. So if you multiply, you will get tan theta plus 5 by 7 equals, if you multiply 1 multiplied by 7 by 5 minus this, if you multiply 7 by 5 cancel, minus tan theta. So now bring it to this side, 2 tan theta equal to this value, right? This is 49 minus 25, 49 minus 25, that is 24. Okay, so that means tan theta equals, so 24 divided by 5 multiplied by 7, so that is 35. So that means tan theta equal to 12 divided by 35. Okay, because 2 tan theta is 24 divided by 35. Okay, so tan theta is known. So from tan theta we can find cos theta, we can find sin theta. So then we can use our polar form to find our required equation, required point z. So z equal to r multiplied by cos theta plus I sin theta. But what is r? The modulus of z that we found already. So that is 7 multiplied by cos theta. Cos theta you have to find from that triangle. Okay, because tan theta is known, 12 divided by 35, cos theta can be found, similarly sin theta can be found. So that means our required value of z equals this r is 7 multiplied by cos theta. What is cos theta? So tan theta is 12 divided by 35, right? So right angle triangle. So what is that? 35 divided by square root of this, right? So 35 square. So this is 35 divided by square root of 35 square plus 12 square. 35 square plus 12 square. Plus similarly sin theta. What is sin theta? 12 divided by same value, right? That means it is 12r. So that's also, that is a required answer. So you have to find this value, right? 35 square plus 12 square. So that is 7 multiplied by 35 plus 12i divided by square root of 35 square. So 1225 plus 12 square is 144. So that is 7 multiplied by 35 plus 12i divided by, okay, so 1225 plus 144. So that is same as square root of 3 2 plus 4 6 and 9. So 1369. So that's also, this is our required answer, right? So that's all. It is similar to the last question, a bit complicated because that point is not on x-axis, right? The center. So that's all. So we use some trigonometry here. See, essentially what we need is the modulus of z. So that we found easily. Okay, but we also need the argument, right? So theta, but theta is found only using this method, right? Because using that right angle triangle, in that right angle triangle the angle is known phi, the total angle is known theta plus phi. From that we find theta using that tan A plus B formula. Okay, yes. So now using the polar form of the complex number, so r is the modulus that is known, and cos theta sin theta can be found using tan theta. Okay, so that is the required answer. Here two complex numbers are given, w and z, which are related by this expression, right? W equal to z plus 2i divided by z minus 2i. Now something is given about z, right? Z, imaginary part of z is less than 0. Using that we have to find the condition satisfied by w, right? Or the locus of w. Alright, so it is given that w equals z plus 2i divided by z minus 2i. Okay, and some condition satisfied by z is also given, right? So for that, what do? You find z in terms of w, right? Here w is written in terms of z, you find z in terms of w by multiplying. You can multiply, or we can also use this component or dividend rule, right? So if you don't want to use that, we can simply use multiplication, but let me use component or dividend rule, right? Numerator plus denominator divided by numerator minus denominator, that equals, same thing you do here also. So that is numerator plus denominator. So 2z, numerator minus denominator, that is 4i. Okay, so that will give you z. So this will give you z. So 1 divided by 2i. So 2i multiplied by w plus 1 divided by w minus 1. That's all. This is z in terms of w. But it is given that imaginary part of w is imaginary part of z is less than 0. So find the imaginary part. What is the formula for imaginary part? So that is z minus z bar divided by 2i. So that is less than 0. Okay. So z minus z bar by 2i, that is the formula for imaginary part. So but z is not this one. So just substitute here. So what is that as it is written? So 2i multiplied by w plus 1 divided by w minus 1 minus conjugate of that. What is the conjugate of this? 2i conjugate is minus 2i. Okay, 2i conjugate is minus 2i. And the conjugate of this, that is w bar plus 1 divided by w bar minus 1. Okay, so this divided by this 2i. So that is less than 0. Okay, now just simplification. 2i can be cancelled, and if you multiply, if you cross multiply, it is w bar plus w bar minus w minus 1. So this becomes plus. So plus, so if you multiply this one, w bar and then minus w bar plus w minus 1, that is less than 0. Okay, yes. Now these values get cancelled, right? W bar minus w bar, so these cancel. So which means we are getting w bar, so is less than 1. Okay, dividing by 2. What is w bar? That is modulus of w the whole square. So taking square root. So that's all. Modulus of w less than 1. That's all. So that is the condition satisfied by w. But what is this modulus of w less than 1? What is modulus of w equal to 1? That is a circle with center, origin and radius 1, but not equal to 1. So less than 1, that means not on the circle but all the points inside the circle, right? That's all, right? W is the locus of w is a circle, the interior of a circle. Okay, which circle? Center, origin and radius 1, right? Modulus of z equal to 1, so that is a circle, but here less than. So that means it is the points inside the circle, right? So that's all. So that is the locus of the circle. All right, yes. So that's it. All right, so that is the answer. So far we have done questions based on just one locus, that is modulus of z minus a equal to r, which is a circle with center a and radius r. Now we will do the next locus. So that is argument of z equal to some constant angle alpha. See, argument is constant. Last one was about modulus. Modulus constant. Circle. Argument constant. What is it? See, now take a point z which has argument alpha. Okay, now you connect all the points which have the same argument, that line or a curve, that is called the locus, right? So take one complex number z having argument alpha, which means line joining that point to origin makes angle alpha with the x-axis. Is there any other point which has the same argument alpha? Any point on that line will have the same argument, right? So take the same line, you take any point on the same line which will have argument alpha. That means what is the locus? That is just a straight line. That's all. So that straight line making angle alpha passing through origin, right? So that straight line making angle alpha with x-axis. So that is the locus of this, right? Yes. But you should not take the complete straight line. What if you extend this straight line on the other side? You take a point on the other side, the negative region. So there is this complex number z having the same argument alpha? No, this angle is in the third quadrant, but that is little more than minus pi, right? That means no, we should not take the complete straight line, only one part of the straight line. We can call it just a ray. Even origin is not included. 0. What is the argument of 0? It is not defined, right? You should not include origin in that locus. So it starts from origin but not including origin, right? Open at origin. So it is just a ray. Argument of z equal to alpha is a ray or a part of a straight line. So one side it goes to infinity, the other side is bounded, right? So this is a ray. Now we will generalize it. More generally, argument of z equal to alpha. More generally, argument of z minus a equal to alpha for some a constant value, right? Constant complex number. Okay. So what is the difference? What is the meaning of argument of z minus a? That is the angle made by the line joining z and a with the x-axis, right? So that means this angle is alpha. So what is the only difference? Instead of starting from origin, this time that ray will start from a. Again, not including a, right? It is open because if z is a, argument of 0, that is not defined. So it is the ray which starts from a but not including a, one part of the straight line, one side of the straight line we can say. So that's also, this is our next locus. All right, what is that? Argument of z minus a equal to some constant angle alpha. Then the locus of z is a part of a straight line, if not the complete straight line. It is just a one side, right? One side it tends to infinity, so it is a ray. Okay, yes. Now we will do some simple questions based on this locus. Okay. Here two curves are given. We have to find the number of points of intersection of these two curves, right? So simply we have to draw these curves, right? So what is the first one? So one of them is modulus of z minus 3 equal to 5. That is a circle with center 3 and radius 5, right? That can be easily drawn. So that's all. That is a circle. Okay. So center 3 and radius 5. Okay, drawn. Okay. Next one is of the form argument of z minus a equal to alpha, right? So it is of the form argument of z minus a, right? So z minus 5 plus 4i equal to alpha. So that is pi by 3. So argument of z minus a equal to alpha is a ray, right, which starts at the point 5 plus 4i. Okay, yes. Then you have to draw this and then find the number of intersections. This is a line, right? If not the complete line, at least a part of a line. The other one is a circle. A circle and a line can have at most 2 intersections, right? So maybe 1 or 0, right? Let us see. Okay, yes, draw this. So circle is drawn. Now we're not sure where this point is, 5 plus 4i. Is it inside the circle or outside the circle? We have to check that, right? So that makes a difference. If the point is outside the circle, maybe there is no intersection, so we don't know. So we have to check whether the point is inside or outside the circle. What do you have to do? We have to find the distance between this point and the center of the circle. So what is this point? 5 plus 4i minus the center. But what is the center? 3. If that distance is less than the radius, the point is inside the circle. If that is more than the radius, the point is outside the circle. So let us find this distance. So this distance is modulus of 2 plus 4i. That is square root of 20. So is it more or less than the radius? So the radius of the circle is 5. So this value is less than radius 5. That means the point is inside the circle only. Okay, so that's all. So 5 plus 4i is inside the circle. So there is a circle and there is a point 5 plus 4i. Now our ray makes angle 30 degree, right? Pi by 6, 60 degree with the x-axis. That means this is our required ray. So how many intersections? Just one intersection, that's all. So it depends on where the point is, right? So if the point is outside, suppose here, the point is here, then it may have no intersection. Or if the point is here, it may have 2 intersections. So it depends on the position of the point 5 plus 4i. But in this case, the point is inside the circle. So that means there is only one point of intersection. So just one point of intersection. So that's all, right? We just have to draw these two curves and then find the number of intersections. That's all, right? So in this case, it happens to be just one point. Okay. Here we have to find the area of the region given by these inequalities, right? So inequalities, see, modulus of z lies between 3 and 4. That means modulus of z is less than 4. Modulus of z is equal to 4. So that is a circle. Modulus of z equal to 3. That is also a circle, but lies between this, which means outside one of the circles and inside the other circle, right? Yes. So modulus of z equal to 3. What is that? That is a circle with center origin and radius 3. So that is the circle. Okay. Now modulus of z is equal to 4. So that is also a circle, same center origin but radius 4. So that is a circle. But this time the inequality, that means modulus of z is greater than 3 but less than 4. That means in between these two circles. Alright, so our region is between these two circles. Outside one of the circle, inside the other circle. Okay, done. Now next one. Argument of z lies between pi by 4 and pi by 3. Again, argument of z is pi by 3. That is a ray, right, starting from origin and then making angle 45 degree with x-axis. That is a ray. Now similarly the other one, argument of z is equal to pi by 3. So that is also a ray making angle 60 degrees. So that means that is also a ray. But the question is, this argument, our argument of z lies between these two values, which means argument is greater than pi by 4 and less than pi by 3, which means between these two. Okay, it is not just one straight line but between these two straight lines. So argument of our required z lies between this. Okay, that's all. Now the intersection of these two. So what are the conditions? Our point z lies between these two circles and also between these two rays. That means this is the region, right? That's all. So this is the region whose area we have to find. So that's all. That is very simple, right? So what do we have to do? It is like area of sector, right? Area of sector, correct? So area of sector, how will you find out? It's not complete area of sector. So take the area of the bigger sector and area of the smaller sector is subtracted. Okay, only that remaining portion. Okay, so area of sector. I mean the difference between the areas of the two sectors. Okay, what is the area of the bigger sector? What is the area of sector formula? So that has formula half r square theta, right? This is the formula for area of sector, right? Theta is written in terms of radian. So that is the formula for area of sector. So that means our required area here equals, so let us take the bigger sector. So that is half r square. R is 4 here, bigger one, right? R is 4 square theta. Theta is what? That is the angle of the sector. So that is what? 60 degree minus 45 degree, right? 60 minus 45, because see, this is 45 degree pi by 4 and that is 60. Now in between we have the angle 60 minus 45. 15 degree are pi by 3 minus pi by 4. So that is pi by 12. Pi by 12, right? Okay, so that is the angle. Okay, that is the area of the bigger sector. From that you subtract the area of the smaller sector. So what is that? So that has the radius 3. Radius is 3 but angle is same pi by 12, right? So that means half 3 square pi by 12. So that's also, this is the answer. Okay, so this will be 4 square minus 3 square. So this is pi by 24. We can take out 4 square minus 3 square, right? 16 minus 9, so that is 7. So that's all, that is the answer, right? So 7 pi by 24, so that is the area, right? So we just have to know what is the meaning of that argument equal to pi by 4. Our argument is greater than pi by 4, less than pi by 3. That's all. Otherwise, so we can use the basic geometry to get the answer. Okay, so that's all, 7 pi by 24. So the next locus is this one. So modulus of z minus a by z minus b equals 1. See, a and b are fixed complex numbers, right? Z is the variable complex number whose locus we have to find. Alright, yes. What does it mean, modulus of z minus a by z minus b equals 1? See, we can write like this. So this can be written as modulus of z minus a. You can multiply z minus b, right? We can separate it, division only. Modulus can be separated. So modulus of z minus a equals z minus b. So we'll understand the geometrical meaning of this. See, a and b are fixed complex numbers. So like this. So a is one complex number, b is another complex number. Where is the complex number z? See, z minus a, that means the distance between the two, z and a. That distance is same as this distance between z and b. So z is equidistant from these 2 points a and b. That is the meaning of this statement, right? So the distance between z and a is same as the distance between z and b. So z is equidistant from a and b. Maybe z is at the midpoint, not necessarily. It can be any point on the perpendicular bisector. What is perpendicular bisector? So that is the locus of a point which is equidistant from the two given points. So if you take any point on the perpendicular bisector, so that point will be equidistant from these 2 points. That means the locus of z is the straight line, right, which is a perpendicular bisector of a and b, right? So that means, so this locus is the perpendicular bisector of these 2 points, right? So a and b. So that's all, simple. It is a straight line. Okay, so just remember this, modulus of z minus a by z minus b equal to 1. So then it is the locus of z is the perpendicular bisector of these 2 points a and b. All right, yes. See, for example, so this question, this equation given here is of the same form, right? Modulus of z minus a by z minus b equal to 1, where a here is 5i and b is minus 3i. right? Now we have to take the midpoint, right? The perpendicular bisector. Where is the point 5i? That is on y-axis, right? The 5 units from origin, right? 5i. Similarly, minus 3i on negative y-axis. Now we have to find the perpendicular bisector of these two. Obviously, the perpendicular bisector will be parallel to x-axis, right? And where the midpoint of these two, what is the midpoint? Just find the average, right? 5i minus 3i divided by 2. So that is 2i by 2i. So I is the point through which this line passes. See here, this line is parallel to x-axis, the perpendicular bisector of these 2 points, parallel to x-axis, and also it passes through the point I. So that means the imaginary part of this any point on this line, so that is constant, right? What is imaginary part? Y value. Because the line is parallel to x-axis, y value is constant. What is the value of y? So that is 1, right? I means the imaginary part is 1. So that means imaginary part is constant for any point on this line. So that's all. So that is the answer. Imaginary part of z is 1 for any point on the perpendicular bisector. So that is the answer. The next locus is of the form modulus of z minus a by z minus b equal to k, where k is not equal to 1. We have already done the case when k is equal to 1, right? That is a straight line, the perpendicular bisector of the 2 points a and b. But here k is not equal to 1. Obviously k has to be positive, right? Modulus has to be positive, but k is not equal to 1. Then it is not a straight line, it is a circle. How is it a circle? Now we will derive that later, but at least for now, you just remember that it is a circle when k is not equal to 1. Modulus of z minus a by z minus b equal to 2 or 3 or 1 by 2. In all these cases, it will be a circle, right? Now, if the circle equation is given in the basic form, like modulus of z minus a equal to r, then it is directly known what the center and radius of the circle are, right? So a is the center and r is the radius. But here it is not obvious. We have to do some calculation to get the center and the radius. But for now, we only know that it is a circle. Okay, yes. Now to get the center and the radius of this circle, you have to know the Cartesian equation of the circle. If you have not done the circle chapter, so this is the equation of a circle. For now, you just have to remember this one point. So this is generally the equation of a circle. Equation of a circle in two-dimensional plane is of the form x square plus y square plus 2gx plus 2fy plus c equal to 0. See, it has some x square term, y square term, both having the same coefficient, and then there is some x term. The coefficient of x is taken as some 2g. Similarly, y 2fy plus c equal to 0. If an equation is of this form, it is a circle equation. For this circle, you have to know the center, right? This is the formula for center, that is minus g comma minus f. That is the center of the circle. And then the radius is given by the formula, the square root of g square plus f square minus c. So this much you have to remember for now. About this circle in detail, that is done in the chapter circle, right, in conic section. But here you just have to remember this one point. This is a circle equation, and the center of the circle and radius of the circle are known by this expression, right? Yes, that's all. For example, if the circle equation is given like this, see, for example, this is the x square y square minus 2x plus 4y plus 1 equal to 0. So this is the equation of a circle because it is of that form. Then we can find its center. What is the center? See, g minus g comma minus f. But what is the value of g? We have to compare the coefficients of x. See here, coefficient of x is minus 2, there it is 2g. So 2g is minus 2, g value is minus 1. That means what is minus g? So that is 1. Alright, just comparing this equation with other standard equation. So that is 2g is minus 2, so g is minus 1. But the center is minus g. So that means minus of minus 1, 1. Okay, similarly, f. So what is 2f? 2f is the coefficient of y, that is 4 here. So f is 2. F is 2, but the formula is minus f, so that means minus 2. Okay, so that's also, that is the center, just comparing with the known equation, so we can get the center. Similarly, the radius. So what is the radius? The square root of g square. So g square we know, right? So g is minus 1, so it is so 1 square. Anyway, square, so no need of negative sign. So 2 square minus c. So c is 1 here. That means, so 1 gets cancelled. 2 is the radius of the circle, right? So 1 comma minus 2 is the center, and 2 is the radius of the circle. That's all. If the equation of circle is written in this form, we can directly write the center and radius using this idea, right? So that's all. So let us take another example. So you want to find the center and radius of this circle, okay? 2x square plus 2y square plus 3x minus 2y minus 3 equals 0. So this is the circle equation. You have to find the center and radius. Okay, how to find the center? See, first of all, this is not of that form. So that form has coefficient of x square 1, coefficient of y square is also 1, but here it is different. Okay, same value, it has to be same value, otherwise it is not a circle, but it's not 1. So you make it 1 first of all to get it in that form. Only then we can write the center and radius. So we can divide by 2. So x square plus y square plus 3 by 2x minus y minus 3 by 2 equal to 0. Just dividing by 2. Now it is properly in that form only. Now what is 2g? 2g is 3 by 2, the coefficient of x. So g is 3 by 4. That means the center is minus of that, minus of g. So that means minus 3 by 4. And similarly, the y coordinate, so that is this one. So 1 by 2. Alright, because 2f is minus 1. So f is minus 1 by 2. So that's all. So that is the center. Radius, square root of g square. So g square is this square, we can square this one. So it is 9 divided by 16 plus this square. So it is 1 divided by 4 minus c. But c is minus 3 by 2. So that means this is plus 3 divided by 2. So that's all. So that will give you the radius of the circle. So that is what is this value? So 9 plus this is 4. 13 plus 24. Right, 24 plus 9, so that is 33 plus 33 plus 4, so 37. So root 37 divided by 4. Okay, anyway, so we can do the calculation to get the center. So we have to bring it to that form, and then you can compare to find the center and radius. So this much you have to remember to get the center and radius of a circle given in the complex form like this. So we have to convert that into Cartesian form and then use this idea to find the center and the radius. Okay. Here in this question, we have to find the center and the radius of this circle, right? Yes. Now we can convert this into the Cartesian form and then find the center and radius using the formula we've discussed, right? X square plus y square form. So we can get it in that form. But here, a and b are complex number which are not known exactly, right? So if you find the center and radius without converting this into the Cartesian form, that will be like a formula, right? Yes. Let us use simple geometry to find the center and radius of this circle. Okay, yes. Now, what is the meaning of this? See, modulus of z minus a divided by z minus b equal to k. K means k is to 1. So that means z divides these 2 points a and b in the ratio k is to 1. So it is like this. So this is the point z which divides the line segment joining this a and b in the ratio k is to 1. That is the meaning of this distance z minus a and that distance z minus b. So that ratio is k is to 1. Okay, yes. Now that is one of the points. Like that there are many points, right? Joining all the points we get a circle. So this is a circle, but that passes through the point which divides in the ratio k is to 1. It also crosses other point. If you extend that line, it also cuts, the circle also cuts the line at the other end. So these 2 points are diametrically opposite points, right? But this point divides internally. This point between this a and b, that divides internally in the ratio k is to 1, and that point divides externally in the same ratio k is to 1. Any point on the circle divides in the same ratio k is to 1, but this divides internally, that externally, taking this point as z1 and that point as z2. Let us find the points z1 and z2. Okay, so what is z2? Z1 divides this line segment joining a and b in the ratio k is to 1. So we can use section formula to find z1. So z1 can be found using this formula. So z1 equals, it divides in the ratio k is to 1. K times b plus 1 times a divided by k plus 1. So that's all. So k b plus a divided by k plus 1. So that is z1. Similarly, z2 can be found. z2 also divides in the same ratio but externally. So the formula is minus, right? There's a minus sign. So kb minus a divided by k minus 1. So what are these z1 and z2? So these are two diametrically opposite points on the circle. Once you know the diametrically opposite points, right, the two ends of the diameter, we can find the equation of the circle, right? I mean the center and the radius, right? The midpoint of these 2 points is the required center. That's all. Find the midpoint. Similarly, you find the distance between these 2 points, that will be the diameter. Half of that will give you the radius of the circle. That's all. So let us find the midpoint. So center is the midpoint of these 2 points. So center equals Z1 plus Z2 divided by 2. The midpoint of the 2 endpoints of diameter, right? So that's all. So we can simplify this. So that is KB plus A divided by K plus 1 plus KB minus A by K minus 1, the whole thing divided by 2. So that is the center. Okay, let us simplify this. So that gives you, okay, so if you take LCM and also it will become 2 K square minus 1, and then so multiply this. So this is K multiplied by this K square B, and here also we have a K square B. So 2K square B. Alright, so next one. So Ka, okay, and here it is minus Ka, so that will get cancelled, and then minus Kb. Alright, so then plus Kb, that will also get cancelled. So this is minus A and minus A, so minus 2A. So that's all. If you divide by 2, we'll get something like this: K square B minus A divided by K square minus 1. So that's all. So this is the center of the given circle, right? So that's all. We found the 2 diametrically opposite points, and then find the midpoint, we get the center of the circle. Alright, yes. So center is found. Now we also have to find the radius of the circle. So that is the distance between these 2 points, right? So that is the diameter. Half of that will give you the radius, right? Because these 2 are endpoints of diameter. Find the distance between them. But how to find the distance between them? So for finding the distance between 2 complex numbers, you just have to find the difference, right? This minus this and take modulus. That's all. So half of modulus of the difference, Z1 minus Z2. Okay, so that's it. Just find the difference. So this is half of KB plus A divided by K plus 1 minus of KB minus A divided by K minus 1. So simple calculation here, that's it. So that is K square minus 1. Yeah, so if you simplify this, you get K square B minus K square B, that gets cancelled, and AK and plus AK, so 2AK, 2K, and then minus KB minus this is minus KB minus 2KB. That's all, right? So minus A plus A, that gets cancelled. So that's also 2 also gets cancelled. So that is modulus of K multiplied by A minus B divided by K square minus 1. So that's it. So this is the radius of the circle. See, you can use it as a formula, right? Or if you don't want to remember, so we can use that the Cartesian method, converting the equation of circle in the Cartesian form, and then you can use that minus G minus F formula to find the center and radius. But if you remember this, you can substitute here also. So you know the value of K, A, B, everything, you can substitute also here to get the center and radius. Alright, so that's all. So this is the center of the circle, and also the radius of the circle is this one. Okay. Here again we have to find the center and radius of the circle, but this time we will not use any formula, we will just use the Cartesian form. We will convert this equation in the Cartesian form, equation of real variables, and then we have the formula for center and radius minus G minus F, and the formula for radius. So let us use that form here. Okay, yes. Now, so this is the equation given here. So if you multiply, you will get this one, Z minus 4I, so that equals 2 times this if you cross multiply. So modulus of Z minus 2. So this is the equation given here, right? In the complex form, Z is a complex variable, but we will convert into real variable. For that, we will assume that Z equal to, so that is the general point, right? So X plus IY. So that is Z. That's all. Let us substitute it here. So if you do that substitution, so it is 2 modulus of, okay, X plus IY minus 4I. That equals modulus of X plus Iy minus 2. Okay, so let's simplify this. Let's take the modulus of this. So that is 2. So modulus means what? Real part square, which is x square. That's all. The square root of x square plus imaginary part is y minus 4. So y minus 4 square. So that equals similarly square root of the real part is x minus 2. So x minus 2 square plus y square. So let us simplify this. So if you square this, 4x square plus y square minus 8y plus 16, that equals x square minus 4x plus y square plus 4. Okay, yes, 4x square minus x square, so that is 3x square, and then 4y square, y square there, so plus 3y square plus 4x minus 32y, and then we have 4 multiplied by 16, so that is 64 minus 4, so that is 60. Okay, so this is the equation of the circle. Now we have to find the center and radius like we did already. So 3 we don't want here, so we want this coefficient to be 1, so divide this by 3, x square plus y square plus 4 by 3x minus 32 by 3y plus 20 equals 0. So that's all. So what is the center formula? Minus g minus f. So minus g minus f. So what is 2g? 4 by 3. That means g is 2 by 3. Right? 2gx. So g is 2 by 3. Minus g we want. So minus 2 by 3. Similarly, 2f is minus 32 by 3. So f is minus 16 by 3. So it is 16 divided by 3. So that is the center. Now radius has the formula. So the radius is square root of g square, right? G square plus f square, which means the square of this, that is 4 by 9, and this is 256 divided by 9, right? Minus c. C is 20, minus 20. Okay, so that's it. So if you do the simplification, so that is 1 divided by 3 root of, okay, so this is 260. 260 minus 9 times 20, right? That is 180. So we'll get 80. That's all. So 80 divided by, so square root of 80 divided by 3. So that is the required answer. So we can also simplify this. 4 root 5 divided by 3. Okay, so that's all. So that is the required radius. So this is the easier method instead of remembering that formula. All right, so just remember this, because anyway you have to remember this formula, minus g minus f, for the coordinate geometry. So center is minus g minus f, radius is root g square plus f square minus c. Once you convert this equation in the complex form into the equation of real variables x and y, just do this substitution. Okay, z equal to x plus iy. It is converted into a known equation of circle. This is a known equation of circle in real variables. So we have the center and radius. So that is the answer. Okay.